Assalamualaikum and very good day to all panels and everyone who is watching my video. My name is Nik Muhammad Nazrul bin Ashari and I am final year Bachelor of Science with honor of Applied Chemistry student of UiT Tempelis. I am supervised by Madam Rosnani Nazri and today I will presenting final year project entitled A Review on Water Quality Monitoring by Forebay Treatment Process. There are three main parts that I would like to discuss here, which is introduction, literature review, and lastly conclusion and recommendation. In background of study, pollution of the water that gives a lot of negative impact to the environment is particularly serious. Industrial, farming, and household use in Malaysia usually release their waste into rivers, ecological system that contain water species such as fish and even river water, which is also consumed by humans. The need for clean water has risen in tandem with the growth of the population and the numbers of industries. In terms of high population in these states, give a negative impact on the quality of river water. Sedimentation of the particle in a river is one of the major problems that occur from the human's occupations. Generally, sediment is referred to the mixture of materials, organic and inorganic, which are carried out by the water, and pollutants are created as a result of biological, chemical and physical processes. Due to the extensive potential of sediment in river, the prospect of water quality monitoring by using Forebay concept was reviewed in this study. In problem statement, over the few decades, environmental river pollution caused by the low quality of turbidity or sediment has become one of the most debated issues due to its toxicity to human life. This environmental river pollution due to the bad sediment comes from many sources, especially from the peripherals. The ideal situation of our river should be clear and by increasing the water quality index in the chemical, physical or biological sectors. Poor water quality can disrupt the natural ecology, disrupting the food chain and reducing aquatic life and wildlife populations. The toxicity from agriculture reacts with molecules in a river that will produce a colloid or sediment. This will cause the river to be murkier, then the sediment will settle down and make the river shallow and increase turbidity. To overcome this problem, there is one of the conventional methods by using a Forebay concept as obstructing a sediment before it released to river. To reduce peak flow rates and eliminate particulate-bound contaminants, Forebay concept temporarily hold and gently discharge the water, which has a permanent pool of water to promote sedimentation and provide additional storage capacity above the permanent pool to detain and slowly release stormwater runoff, thereby mitigating peak flow rates. There are three types of objectives in the study, which is to compare the sediment Forebay system available in improving the water quality for rivers, to identify the water quality index physico-chemical properties in measuring the river's health, and lastly, to determine the techniques and systems design available in improving the water quality of the rivers. The research question of this study is how Forebay system works to improve water quality, what advantages and disadvantages of Forebay treatment, what technique used to determine water quality, what physico-chemical properties to determine the water quality index, and lastly, what is impact on ecosystem due to low water quality. Now, we continue to the literature review. For application of Forebay systems, a Forebay is a man-made waterway in front of a bigger body of water. Forebays serve a variety of purposes. For example, these are used in flood management to function as a backstop during floods or weather conditions, detains water and discharging it into a bigger body of water in a controlled manner. Several Forebays are mainly utilized to provide a natural environment for plants and wildlife to offset the dam or reservoirs' environmental effect. The size of Forebays varies substantially depending on their location and use. In this review study, there are several types of Forebay that use as an improving water quality. Firstly is wet retention pond. For several water pollutants, the effectiveness of urban wet retention pond has been widely examined. To reduce peak flow rates and eliminate particulate-bound contaminants, wet retention ponds temporarily hold and gently discharge rainwater. Wet retention pond, on the other hand, with sandy underlying soils, may give extra advantages via infiltration, discharging groundwater and maintaining stream-based flow. It contains a permanent water pool to promote sedimentation and extra storage capacity above the permanent pool to hold and gently release stormwater runoff, hence reducing peak flow rates. The efficiency of sedimentation is determined by the particle size distribution of the influent. Sand is trapped, but clay and fine silts are often suspended in the water column. Second is Forebay macropool. In this figure, a sediment forebay is a tiny hardened basin at the entry of the detention basin. A forebay is used to distribute input into a shallow, broad bay that is generally surrounded by a riprap or a concrete embankment. A forebay is a stormwater pre-treatment structure that is designed to settle down heavy or coarse particles. The regular maintenance work in the macropool may be greatly reduced with a forebay. To eliminate the sediment accumulation, a forebay requires seasonal cleanup operation. A floor pipe or a vertical wall slot may be used to provide the low flow exit. A macropool is a sunken wet pool created in front of the outflow structure that may operate as a submerged inverted siphon device. As illustrated in this figure, due to the clogging around the outlet structure, continuously draining water as soon as the hydraulic head is created. Standing water in the basin creates enough headwater to force water through the space between the screen and the plate. The siphon flow will continue until the basin is completely empty. The third is floating treatment wetland. Floating treatment wetland systems are specially engineered devices that mimic the water treatment processes that occur naturally on and around floating vegetated island. By contributing the water treatment process including as adhesion, filtration, nutrient absorption, direct use by plants, and sequestration. Floating treatment wetland may help to enhance the water quality of water storage ponds. This system, which consists of floating porous mats that are planted with wetland vegetation and are implemented in new or existing wet ponds or basins to enhance water quality treatment. By decreasing flow velocity and promoting the settling of suspended materials, floating treatment wetlands contribute the health of their aquatic environments. Floating treatment wetland also filter suspended particulates mechanically by the contact of plant roots in the water column, which may grow to a depth of 3 meters as seen in this figure. This figure shows how young plants are planted directly into these floating matrix, with roots growing into the water column. These systems, which consist of floating porous mats that are planted with wetland vegetation and are implemented in new or existing wet ponds or basins to enhance water quality treatment, are made up of floating porous mats that are planted with wetland vegetation. In outcome of Forebay treatment process in wet retention pond. Wet pond performance may be predicted by the proportion of surface area to drainage area, with 1 to 2% suggested to fulfill water quality requirements. This method discovered that young ponds remove more contaminants than older ponds, suggesting that dredging and other maintenance may be required to guarantee long-term functioning. Based on the research by Senduran 2018, the method has some effectiveness in reducing total suspended solid, certain heavy metal, and total phosphorus all at the same time. Total suspended solid is removed from conventional wetland system by settling, filtration, and adsorption, as well as other organic material and nutrients linked with it via processes such as mineralization, metabolization. Hence, the total removal efficiency of the system is almost similar. In Forebay and macropool, a macropool serves as a backup mechanism in the event that the outflow structure becomes clogged. The macropool principal function is to ensure that the drain time and flow release rate are guaranteed under the specified conditions. Because of this large flow volume and scattered debris loads, a retention basin is seldom cooked during an intense storm. The success of trapping solid settlement in the Forebay and macropool is determined by the basin's resident time or drain time. In general, the larger particle trap ratio, the longer the resident duration. For floating treatment wetland, this treatment had no significant influence on overall water quality according to data from discrete and high-frequency sampling. Floating treatment wetlands are a successful treatment method for removing pollutants from urban stormwater runoff, but they may require to cover more than 0.14% of the contributing catchment to meet locally mandated water quality standard of 80% total suspended solid, 60% of total phosphorus, and 40% of total nitrogen. Now, I would like to discuss about the types of parameters to indicate water quality. Water quality is a set of guidelines that outlines the biological, chemical, and physical characteristics of water in relation to its intended use. As a result, water quality assessment may be defined as a study of the biological, chemical, and physical properties of water in terms of its natural quality, human health, and implication and intended application. In biological agents include toxins, waterborne infection, algae, and bacteria. One of the parameters in biological is fecal coliform. Fecal indicator bacteria including E. coli, coliforms, and enterococci are routinely employed to determine microbial contamination. Fecal coliform is a kind of FIB that has been used in microbial contamination risk assessments in water. In chemicals, human activities are regarded to be the primary source of chemical contamination. Chemical pollution has been identified as one of the top 5 environmental stresses wreaking havoc on the world's biodiversity. The chemical parameters that need to identify is chemical oxygen demand, biological oxygen demand, pH, total suspended solid, dissolved oxygen, salinity, and ammoniacal nitrogen. Lastly, for physical pollution is defined as the introduction of waste items into the environment, and also certain of physical characteristics. The physical parameters that need to identify is temperature and turbidity. Next, water quality standard for river water. The Department of Environment (DOE) assesses the river water quality using the Water Quality Index and the National Water Quality Standards for Malaysia. The DOE's Water Quality Index has been used in Malaysia for nearly 25 years as a foundation for assessing water quality in the environment, while the NWQS assesses the beneficial uses of water courses based on WQI. As a result, water quantity scarcity grows as the amount of good quality water accessible for usage diminishes and water treatment costs rise owing to the presence of additional contaminants. Furthermore, the water bodies and surrounding ecosystems ecological condition deteriorates, harming aquatic life and habitat, as well as recreation activities. All the table shows the National Water Quality Standards for Malaysia. The last point in literature review, negative effect of water pollution. Fresh water is a vital natural resource that is utilized for a variety of functions in our everyday lives, including drinking and development. Pollution level rise, causing instability in our natural environment and harming both physical system and biological things in the ecosystem. In human health, water contamination is a major cause of waterborne infections across the globe, particularly in impoverished national. Water pollution poses a number of health hazards, including cancer, diarrheal illness, respiratory disease, neurological dysfunctions, and cardiovascular disease. When pregnant women are exposed to toxins in polluted water, they are at increased risk and have a detrimental impact, increasing the likelihood of low birth weight. Drinking polluted water may lead to infection, illnesses like typhoid, fever, and cholera. In aquatic, as soon as organic pollution gets into contact with water bodies, it causes deoxygenation and a lack of light, resulting in a decline or even push of algae. Deoxygenation reduces light level, raises TSS, and settles debris, resulting in the decline or extinction of aquatic organisms that are most vulnerable to pollution. Total suspended sediment has a negative influence on algae and aquatic macrophytes because it reduces the amount of light that reaches the water column, lowering the frequency of photosynthesis. Perch, brown trout, and other fish species that depend on sight to grab their meal first are particularly vulnerable to high levels of suspended particle and exhibit considerable avoidance behavior. In conclusion and recommendation, the sediment Forebay system was underexploited compared to the other filtration system in terms of biological potential such as antibacterial properties and antioxidants. The analysis review of sediment Forebay systems proved that the systems contain high potential effectiveness in reducing TSS, certain heavy metal, turbidity, and TP all at the same time via processes including mineralization and metabolization, as well as other organic material and nutrients related to it. So that's all from me. Thank you.